Alright, now I got
Algebra 2, determinants. Alright, now, a determinant. It's a number. Okay, that's what a determinant is. It's a number. You're going to get numbers today. It's a number that you can that comes from any square matrix. We are going to do two of these, two different types. We are going to learn how to do 2 by 2s. We're going to learn how to do 3 by 3s. Once you get past 2 by 2s, or once you get past 3 by 3s, these become very complicated. Okay? 2 by 2s aren't bad. 3 by 3s are a little rougher, but not bad. 4 by 4s, can't even explain to you how to do it. Okay? Okay, to be honest. All right, because I don't fully remember. I did it. I don't remember how to do it by hand. Okay? For the 2 by 2 though, you have a formula for it. It looks like this. Okay? Now, this is the notation to this can sometimes be confusing. You have your regular 2 by 2 matrix. Okay? Matrix A, with elements A, B, C, D. This can be, whenever you need to take the determinant of it, and we'll learn what that is in a little bit, it can be presented to you in two ways. One of the ways is with the abbreviation DET in front and just normal brackets. Okay, brackets around the 2 by 2 matrix. The other way is with just a matrix, like the 4 elements normally written out, but vertical lines surrounding it. They are not absolute value bars. Okay? You're not in the number world, we're in the matrices world. These are not absolute value bars. Those are just the notations. Instead of writing DET, you just put 2 straight vertical lines and leave off the little enclosings for your brackets. Okay? So these are not absolute values. Now, to do the determinant of a 2 by 2 matrix, very easy. Your elements labeled A, B, C, D. You want to take A and D and multiply them together. You want to take B and C, multiply them together, and then subtract the 2. All right, Megan?
Why do you go across like that?
No idea. It's just the way it is.
Isn't determinant the thing that it's like that long equation with it's like plus minus and it's like a square root?
That's discriminant.
Oh, I was close.
Okay, yeah. Well, and the funny part about that is this used to be chapter 3, and discriminants used to be chapter 4. And then so 3 and 4, and then I would be teaching discriminants, and I'd be saying determinants. So yeah, it was a rough time in Mr. Mormon's life, but now it's okay.
fascinating.
Yeah, thrilling in it. So, anybody else? Questions on that? Pretty easy so far. Just notation. Alright, so you are going to see, usually with the 2 by 2s, and this isn't always the case, but most cases with 2 by 2s you'll see the abbreviation DET. With the 3 by 3s you'll see the lines. Okay, but they are interchangeable. You can have a 3 by 3 with the DET, you can have a 2 by 2 with the lines. It just depends on who's writing it, how, and what, basically who wrote the book, who wrote the worksheet, depends. Okay? But to do these, all you need to do is determinant of it. You need to multiply those together. Minus. And multiply those together. And then simplify. So 9 times 5, 45. Minus 8 times negative 4, 32. 45 minus a negative 32, 77. That's it. Okay, that's it. Alexa.
I wasn't here, so is determinant always subtraction?
Yes.
Which one do you put in front?
You do the black first, and then the red second. Yeah, these two first, these two second, minus. So second one, same way. Negative 6 times 8 first. minus 10 times negative 7. And then simplify that. So you got negative 6 times 8, negative 48, minus negative 70. So negative 48 plus 70 gives you, should be what, 22? Okay, next question. I am going to give you a matrix. Let's see here. Let's go 2, negative 2, negative 2, and x. Okay, so your matrix C is a 2 by 2. First row is 2 and x. Second row is negative 2, negative 2. Now, this is one where you'll see the notation given to you like that, okay? Because they set it up just as equation. And your directions here are probably, obviously, figure out what x is. Ideas, thoughts, what do you do?
You set it up the same way and put it equal to negative 15.
Bingo. Set up the exact same way. So, you go down your first diagonal, 2 times negative 2, minus negative 2 times x, except this time you know it equals negative 14 already, and then you work it out to find what x is, solve that quick equation. Okay. So 2 times negative 2 is negative 4, minus a negative 2x, so I'm just going to go ahead and make that plus 2x, right? Equals negative 14. Add the 4 over, which gives you 2x equals negative 10. Divide by 2. X equals negative 5.
Why did you divide first?
Moving on. 3 by 3s.
Oh.
The same thing?
You would hope so, right?
You go across.
You would hope it would be the same thing. Just multiply 4, 2, and 9 minus 3, 2, negative 4. Right? You would hope. But, like the old song goes, you can't always get what you want. So, because you're leaving out 2 numbers. Everybody see that? Right? Negative 3 and 6 on the outsides, in the corners here. You see that? Okay. So, once you move from a 2 by 2 to a 3 by 3, your process changes, but at its core, it's the same. Okay? It changes, but at the core of what you're doing, it's the same thing. So, here's how you do these. You take your first 2 columns and rewrite them on the right side kind of like this. 4, negative 3, negative 4, negative 8, 2, and 5. Okay? Always the first 2, always on the right side of the matrix. Always like that way. Okay? Everybody good? Any questions? Now, your process goes like this. It's kind of like 2 by 2s in the fact that you're going to first go from the top one and down the main diagonal. Okay? Here, let me make that just a little bit darker so we can see it. Okay? Kind of like that. And when you draw that line, you're going to multiply all of that. Okay? So 4 times 2 times 9. Okay? 4 times 2 times 9. 4 times 2 is 8. Times 9 is 72. Okay? So you start at 4 and you go down and to the right. Your next step, go to negative 8. Do the same thing. Except you make sure you extend that line into the negative 4 that you rewrote. Okay? Does everybody see that? multiply along that. So negative 8, 6, and negative 4. Which ends up being 192, is that right? Okay. Do it one more time. Get the 3, the negative 3, and the 5, which ends up being what, negative 45? Add those all up. Okay, so 72 plus 192 minus 45, what, 219? All right. Is everybody good so far? That's half of it. That's half of it, yeah. All right.
It's the other way.
Not exactly it.
What's gonna happen to the negative 3 and the 2 on your outside?
You'll see. So now you can do this a few different ways. It doesn't matter which way you do it. For whatever reason, I was always taught to start here. Okay? That's if you go all the way over here and start the same way, going the opposite way, which is what we're working towards, that's fine. It's not going to change your numbers, but for whatever reason, I was always taught to start on the matrix and go that way. I don't know why. If you want to start over here just because it's all the way to the left and then all the way to the right, which makes sense to me, I can see that, that's fine. But just out of habit, I just go like this. And then you do the exact same thing. Okay? So you go 3 times 2 times negative 4. So what, negative 24? Four, 6, and 5. Which is 120, is that right? And then negative 3, negative 8, and 9. Oh, positive 9, my bad. Which is what, 216? Add those up, you get what, 312? Okay? Everybody same page, yes? Last step. 219 minus 312.
2 and the negative 3.
We'll get there. We'll get there. It's okay. 219 minus 312 equals negative 90 scribble, or 93, like it's supposed to be. Okay. That's your determinant. That's your process. You take your left down diagonals 3 times, multiply them, add them up. You take your 3 right diagonals, multiply them, add them up, subtract the 2. So you can see the similarity in the process to it from a 2 by 2 making the jump to a 3 by 3, right? You're still going down this way minus this way, except you got to do it instead of just one time down, you got to do it 3 times. Okay? That's the major difference, obviously. Okay? Now, this is the setup every time, and every year this question gets asked. So what about this negative 3 and this 2? Here's your deal. The actual process to this is you do this times this times this, add them up. Negative 8 times 6 times negative 4, add them up. And then 3 times negative 3 times 5, which is what you do. Except when you rewrite these 2 columns, you're putting this negative 3 here, so it's in the line with what it's supposed to be multiplied by. You're putting the 2 here, so it's in line with what it's multiplied by. See, you use the negative 3, you use the 2, but you don't use you use the 2 here, you use the negative 3 here. So everything's getting used, but if you didn't rewrite those 2 columns, you would have to remember this diagonal times these 2 with this one, times this one with these 2, minus this diagonal plus these 2 times this one plus this one times these 2, which is way, way, way harder. Okay? So just rewrite the first 2 columns. Always the first two columns, always on the right side. Okay? Any questions? Yes, next one's for you. All right, questions on that? We're not done yet. Okay, March, did you find your boo-boo?
Yeah.
Okay.
I got 400 when I multiplied 6 times 5 times negative 5.
Yeah, that might do it. Okay, now, there are, let's talk and listen to me just a little bit, okay? I showed you guys how to do row reduced echelon form, right? Okay, yeah, exactly. In your calculator, the RREF?
Yes.
Right? Okay. Now, before that came about, all right, let me get a clean slate up here. Everybody good? Okay. Yeah? Okay, before that came about, I'm going to write a two equation, two unknown. You don't need to write this, just watch me. Okay? There's your system of equations. We know how to solve those. Graphing, substitution, elimination, blah, 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 blah. There's another way. This way is called Cramer's rule. Okay? What Cramer's rule does is it uses the coefficients of the system and the coefficients from the two equal sides on the right. Okay? And basically what it is it's two fractions. X equals 1, y equals another. Okay, notice my notation here. The denominator of these fractions is made up from the determinants of your coefficients. 2, 3, negative 3, 7. See that? The numerator, you also make determinants, but see how this one equals x? So instead of writing 2 and negative 3 in its column, you would write 7, 11. Yes, I did that on purpose. I know. And then on the y one, you would write 2 and negative 3. Instead of writing 3 and 7, you would write 7, 11. So it'd be determinant divided by determinant. 2 by 2 divided by 2 by 2. Very quick, very easy. Once you get the notation and you know where the numbers go, it's fast. Because this is just
always gonna be like just an x, just x's and just y's, or is it gonna be like x's, y's, and z's?
You could do x, y's, and z's, and that's where I was taking this. You could do x, y, z's. You could do 4. You could do 5. But think about this: there could come a time when if you had a 3 equation, 3 unknown system, but you only want to find one variable. That's where this comes into play. That's where this is super helpful because you can set up your 2 determinants so you find just that one variable instead of working the system out where you have to find all 3. See what I'm saying? So Cramer's rule is handy if you don't have a calculator or if you don't have the solving system software or anything like that. That's one of the main places where determinants are useful. And that's where I'm going with this little mini rant. Your other place where they are useful is this. Okay? Finding the area of a triangle. Yes. You can find the area of a triangle if you're given the coordinates. We got 15 minutes. Yeah, stop looking at that clock.
What?
We got 15 minutes.
Oh, David asked what time it was.
It's time to get a watch.
Good.
David, just click your iPad.
Now, you can find the area of a triangle by taking your coordinates of said triangle. All right, now notice up here in the definition, A, B, C, D, E, F. So you put your x coordinates in one column, A, C, and E. Your y coordinates in the second column, B, D, and F. And you put 1s in the third column. Okay? Megan.
Are the ones like the total or something?
Hmm?
Where are the ones
The ones are there because you have to have a 3 by 3 to do this, since you have 3 coordinates, 3 vertices to a triangle. So you have 1, 2, and 3 here, so then you need that third column because you can only take determinants of square matrices, 2 by 2s, 3 by 3s. So you had to put those ones in there, and then whoever came up with this figured it out. It worked. Why exactly it works, I have no idea. Okay. Now, area of a triangle is what? Just in general. Divide by 2.
Yeah, there's a one.
Hence the 1/2.
Yeah.
Everybody see that? Hence the 1/2. Okay? So you have the 3 coordinates, you have the 3 x's in one column, the 3 y's in another column, 1's in the last column. You take that determinant, you multiply that by 1/2. That's the area of that triangle. Okay? Does that setup make sense? So it's just a 3 by 3 determinant that you pull from the coordinates. But you multiply, once you do that determinant, you multiply it by 1/2 since it's the area of a triangle. Okay?
Wait, where do you get the ones from?
Those are there all the time. That's how it is.
You find the area of a triangle, those are the third column.
That third column is always ones, yes.
Okay, and then, oh, so it's just saying that?
Yeah.
Okay.
Okay. Megan?
When we calculate them, like, are we doing the same thing with the 3 by 3?
Yep. Okay. Now, last thing. Length, width, area, volume, height, surface area, time. It can all not be what? Negative. This is a real problem. You're talking about an area. Area cannot be negative. That's why if you look at the capital A in the definition of the words, that is in absolute value bars. Okay? Which is where the confusion starts. Exactly. Okay? So, here's where your confusion comes up. If you're finding the area of a triangle, you take the absolute value. If you're just doing one like this, you do not.
But it has the 1/2 I'm trying to do.
If you're finding the area of a triangle, then you do it. Okay? Then you take the absolute value. Because there's going to be there's like one situation, there's like one setup of these 3 coordinates that you can put into your triangle and make it work out so that it's positive away. The other 2 ways you put those coordinates in, because they're interchangeable, they'll show up negatives. But you have no way of knowing your order, the correct order to make it positive. For example, you could flip-flop this -4 and 3 with this 3 and 1 respectively, right? Just flip-flop the coordinates. It won't change the number, it might change the sign. That's why this is in place. Okay? I know that was a lot. Does that make sense though? Okay? Last one. Find the area of a triangle with coordinates of 0, 0, 4, 12, and -2, 8. So my suggestion for this is to set it up exactly like the definition had. Put the 1/2 in front like that, and go 0, 0, 1, 4, 12, 1, -2, 8, 1, just like that. And then rewrite, whoops, your 2 columns. Okay? And then once you do it, you multiply it by 1/2. So this last one, obviously, I took it pretty easy on you. Okay? Because I gave you the origin as 1. If you get zeros inside these matrices, your life becomes a lot easier. Okay? Because 0 times 12 times 1 is what? 0. 0. 0 times 1 times -2 is 0. So your left side is 1 times 4 times 8, which is?
That would be
32. Very good.
Yeah.
Okay, so your 3 lefts end up being 32. Okay? Your rights. 1 times 12 times -2.
-24.
-24. 0 times 1 times 8.
0.
0. 0 times 4 times 1. 0. Gritty. So subtract 32 minus a negative 24.
That'd be 56, but then you gotta multiply it by 0.5.
56 times it by half.
28.
There you go. Okay. Now, we got lucky with how we put these coordinates in here. Like I was saying, if you flip-flop these coordinates, this might end up being a negative 56. Where's we at? Right here. This could end up being a negative 56 here. That's where you're okay to take the absolute value because you are talking about the area of a triangle. All right, area has to be positive, so you're allowed to take the absolute value of it when you're taking the area. But don't forget about that times 1/2. Okay, honors had about 7 or 8 of them leave this as their answer and forgot the 1/2. Do not forget the 1/2. Okay. Questions on that?
No.
Everybody okay? It's a little bit of labor. All right, it's not, but it's all multiplications and adds and subtracts. Okay, not terrible.
I feel like once I just do a few of them, I'll be.
You get the hang of it. Yeah. All right. That's it. The end.